All right, we're going to continue on dividing polynomials. This time we're going to use synthetic division. And synthetic division is a shortcut for dividing polynomials by binomials. So remember, binomial is two terms. Of the form x minus k. So example 2, use synthetic division to find 2x cubed minus 5x squared plus 5x minus 2 divided by x minus 1. So the first example we'll use steps, and then the second one we'll just kind of combine all the steps together as one, and then we'll have one where we're going to use the remainder theorem. So step 1, write the terms of the dividends so that the degrees are in descending order. Then write just the coefficients. Again, if any terms are missing, use the coefficient 0. I noticed in your book a lot of the times that it does do it in descending order, but I have seen the ones where it hasn't. So we're going to write them in descending order. So again, we're going to see we have 2, negative 5, 5, and negative 2. Then it says write the constant k of x minus k to the left and bring down the first coefficient as shown. So we are looking at here, we have x minus 1. So if we're going to say x minus 1, we'll have x minus k. So k is equal to 1. So we're going to write it off to the side here. And then we are going to take our 2, negative 5, 5, and negative 2. And we're going to bring down the first one as shown. Okay, now a little thing I do a little different than what the book does is I like to put a line in between the last two terms. And you'll kind of see why I do that here in a second. So I'm going to say put a line between last two terms. Okay, so now we're just going to multiply and add as shown. So I'm going to write it down one more time here for you. So we're going to have 1. And I have my 2, negative 5, 5, negative 2. I'm going to put that line there. All right. And then I'm going to do this. So they told us to bring the first one down, which I did. Now I'm going to multiply 1 times 2. So here I'm going to multiply. So 1 times 2 is 2. And then I'm going to add. So remember, when we were doing polynomial long division, we subtracted. That's kind of what makes this kind of easier to do. So I have negative 5 plus 2, which is going to give me negative 3. And I'm going to do the same thing. So I'm going to multiply 1 times negative 3, which is negative 3. I'm going to add. That'll give me 2 here. 1 times 2 is 2. Negative 2 plus 2 is 0. So the last one after that bar is the remainder. So this is the remainder. Okay. Here's an important point. If it is 0, it tells us x minus 1 is a factor. And that'll be important in the next section for us. All right? So now, what you need to remember, so this one here is your remainder, and then we're just going to see each term going from right to left, and we're going to increase them. So this here is our constant term, or our x raised to the 0 power. This is our x to the first term. This is our x squared term. All right, so now your answer, if you notice, we started with the third power. Your answer will always be 1 less. All right, so on this here, we can say, so what did they have us do? 2x squared, 2x cubed, minus 5x squared plus 5x minus 2, again divided by the binomial x minus 1. Well, when we did it, our answer was 2x squared minus 3x plus 2. So again, our quotient is 1 less degree less than our dividend. Okay? All right. So that was the first one, going step by step. Like I said, we're going to do this next one, and we're going to do it all at the same time. So divide using synthetic division, x to the fourth plus 2x cubed plus 4x minus 20, and we're going to divide that by x plus 6, excuse me. So we're going to look here, and we are going to take our coefficients. So we have 1, we have 2 for the x cubed term. Notice there isn't an x squared term. What did I tell you? You have to put a 0. And then we have 4, and then we have negative 20. And remember, I told you to put the last one here because that'll tell us the last one will be our remainder if we have one. All right? So on this one here, remember, it's x plus 6. But remember, we need to write it as x minus k. So to get that, we'll have x minus a negative 6. So that tells us k is equal to negative 6. So I'm going to put negative 6 here. And again, I'm going to bring the first number down, and then I'm going to multiply. Negative 6 times 1 is negative 6. I'm going to add those. So 2 plus negative 6 is negative 4. Negative 6 times negative 4 is 24. I'm going to add those. 0 plus 24 is 24. So I have negative 6 times 24. Now, right now, some of you are probably bringing out your calculator. So this would be negative 144. 4 plus a negative 140 is negative 140. And let's see, negative 140 times a negative 6 will give us 840. And negative 20 plus 840 is 820. So that's again our remainder. And since there is a remainder, x plus 6 is not a factor. Remember, when we can factor it, then that helps us find our zeros. Okay? So on this one here, then we're going to just say it is equal to, again, same kind of thing. This is our remainder. Here's our constant term. Here is our x term, our x squared term, and our x cubed term, which tells us we probably started with an x to the fourth, which we did. Remember, using synthetic division with a binomial, we're always going to be one less. All right? So then our answer for this problem is going to be x cubed minus 4x squared plus 24x minus 140. And remember, from yesterday, when I had the remainder, I had to put that over my divisor, which in this case is x plus 6. All right, one more to do. So finally, if a polynomial is divided by x minus k, then the remainder is r is equal to f of k. So what they're telling you here is we're just going to find out what our k is. All right, so we'll find out if we have a remainder or not. A lot of times if we start with something big, it's easier to do this remainder theorem than it is to keep working it out. And you'll kind of see as we go along what I'm talking about there as we go along in this chapter. So on this one here, again, use synthetic division to evaluate 4x cubed minus 2x squared plus 5x plus 11 when x is equal to negative 2. So to evaluate f of x when x is equal to negative 2, divide f of x by x minus a negative 2, or x plus 2. And then the remainder will be f of negative 2. So basically what they're saying here is, remember, if I set this, remember, for a factor, we would be setting it equal to 0, right? So we have it set as this. So we're kind of doing the opposite of the zero product property. So then to get x and the 2 on the same side, so we can set it equal to 0, that's kind of what they're just telling you. So that's where this x plus 2 came from. They're trying to make it seem difficult, but it's really not. The thing to remember is when they tell you when x is equal to negative 2, we're not going to change the sign on the outside. The outside one will be negative 2. If it said x is equal to 2, it'd be positive 2 there. If it said it was negative 4, it'd be negative 4. All right? So now we're just going to go ahead and do this real quick. So again, same kind of thing. Let's see. We have 4, we have negative 2, we have negative 5, and we have 11. Put that bar in between the two and bring the first one down. Negative 2 times 4 is negative 8. Negative 2 plus negative 8 is negative 10. Negative 2 times negative 10 is positive 20. Negative 5 plus 20 is equal to positive 15. Negative 2 times 15 is negative 30. And then that will give us 11 plus a negative 30 is negative 19. Again, that is our remainder. If it was 0, we would say that x equals negative 2 is a factor, but it's not. Or we could say that x plus 2 is equal to 0. That would be one of our zero product property ones. But it's not. And that's kind of what they're kind of showing you. So in this case, we know that f of negative 2 is equal to negative 19. And, I keep liking to tell you guys to check. So on this one here, you can always check by taking f of negative 2 and plugging it into the original equation. So again, wherever I see x, I'm replacing it with negative 2. And I've told you whenever I replace a variable, I put parentheses around it. And I have 2 times negative 2 squared minus 5 times negative 2 plus 11. So in here we'll have 4 times negative 8 minus 2 times 4 minus 5 times negative 2 plus 11, which will give us negative 32 minus 8 plus 10 plus 11. If you put that all in your calculator or go from left to right, you'll find out that yes, f of negative 2 does equal negative 19.